Hello. Today we're going to be verifying whether or not two nonlinear functions are inverses of each other. This works the exact same way as when we were determining if linear functions were inverses of each other. We just now start with some roots or some powers in our starting equations. If you think back to when we were checking to see if two equations were inverses of each other before, what we did was we plugged one function into the other. So if we're looking at number one, we start this off by finding f of g of x, which means I'm plugging the entire right-hand side of the g function into the x spot in the f function. So that's going to look like f function starts with a cube root. Give yourself lots of room. Instead of x, you're going to do the whole g function, x minus 2 to the third plus 2. And then back to after x is minus 1 inside the root and minus 1 outside the root. From here, we want to simplify as much as we can. Like terms are something we can look for, but like terms can only be combined if they're both inside or both outside a root or set of parentheses. So I can combine these. So third root stays the same, x minus 2 to the third stays the same, 2 plus 1 is 1, but then I have a minus 1 outside the root. I cannot combine this plus 1 and this minus 1 because 1 is inside the root and 1 is outside the root. I also cannot cancel the cube root and the cubed because not everything inside the root is getting a third power given to it. That 1 doesn't have a third power with it. So I cannot simplify this any further. So my answer here is no, they are not inverses, because remember, if we equal just x at the end, then yes, they are inverses. If we get anything else, that means no, they are not inverses. So let's try a few more just to get the hang of it. Starting once again by plugging one function into the other. If you don't write this f of g of x part, I'm not too worried. I'm going to take all of this and plug it into x in the f function. So that's going to look like fifth root. Give yourself lots of room to write. The whole g function, x minus 1 to the fifth minus 2. Back to this after x is plus 2 inside the root and a plus 1 on the outside. Now let's simplify what we can. Well, I have a minus 2 and a plus 2 inside the root. So minus 2 and a positive 2 plus 2 are opposites, so they cancel. What else can I cancel? Well, I have a fifth root and a fifth power. Everything inside the root has a fifth power on it. So I can cancel fifth root and fifth power, which leaves me with just what was under the root, which is x minus 1. Don't need the parentheses anymore. And I still have that plus 1 at the end. And then I can also cancel minus 1 and plus 1 because those are 0. So I end up with just x. Since I get just x at the end when I'm done simplifying, that means yes, these two functions are inverses. Number 3, same idea. I'm going to find f of g of x. So I'm going to plug the whole g function in for x into the f function. That's going to look like parentheses, the g function, fifth root of x plus 3. Then I have a minus 3 and a fifth power. Inside those parentheses, plus 3 and minus 3 are opposites, so those cancel. Also, I have a fifth root and a fifth power, which are opposites, so those cancel. So I end up with just x, which means yes, those two functions are inverses. The next one has n's instead of x's. It's not a big deal. So what we're looking for number 4 is to see if we just get n at the end. It's the same concept, just with a different variable. So I'm going to plug the f function into the g function. So all of this goes right here. So parentheses, the g function stuff. And then inside my parentheses, I have a minus 2 still, then a fifth power, then a minus 2 on the end. Inside the parentheses, but outside of the root, this plus 2 and this minus 2 cancel each other out because they're opposites. I still have this fifth root of n plus 2 inside the parentheses, a fifth power on the outside, and a minus 2 on the outside. Fifth root and fifth power cancel each other out. And then last but not least, plus 2 and minus 2 cancel each other out because those are opposites. I get just n at the end, which is not x, but since we had n's instead of x, it's the same idea. So since everything cancels except for my variable, that means yes, those two starting equations are inverses of each other. Two more just to make sure we really got it. Number 5, I'm going to plug the h function into the f function. So all of this will go right here. So cube root, give yourself plenty of room, x plus 2 to the third plus 2. Then inside the root, we still have a minus 2. We have another minus 2 at the end. Inside the root, plus 2 and minus 2 are opposites. They cancel. Also, this third root and this third power cancel as well. And last but not least, plus 2 and minus 2 here cancel. We get just x, so yes, those two functions are inverses of each other. Last one, I am going to plug the g function into the f function. So all of this will go here, which is going to look like parentheses. The g stuff, cube root of x minus 1, plus 2 on the outside. Then I still have another minus 2 inside the parentheses, third power, and then a plus 2 at the end. Inside the parentheses, plus 2 and minus 2 are opposites, so they cancel. I still have cube root of x minus 1, third power on the outside there, and then a plus 2. Moving right along here. I can cancel the root and the power. I get x minus 1 plus 2. And then I can combine the 1 and the 2. I don't end up with just x, I end up with x plus 1. Since I don't get just x, I have something else left. That means no, those two functions are not inverses of each other. So if everything cancels except for your variable, yes, the two functions are inverses. If you have things left over other than just your variable, no, they are not inverses. To figure that all out, remember you're plugging one function into the other. I usually do bottom function into top function, but either way around would work. That is it for today. I hope you have a wonderful day.